is we're doing the opposite of FOIL. So the warm-up question is asking us to do FOIL. So like yesterday we did distributive property, and then we did the opposite of that in our notes. So we're doing the same thing today. So we either do FOIL or box method here. And then, so what we're going to be doing is then we'll get the opposite of that when we go the other way. So, we combine those like terms in the middle. Same idea here. Again, it doesn't matter which way you want to do this. So, what we're doing today is we'll get the bottom line of information, and we want to go back to, guys, back to the factored version. So we want to go back to where it's written in 2 sets of parentheses. And again, you guys, we learned this in algebra, but at the same time, it's not like you use this every day, so it's something we probably forgot. But like I said, I think this is probably most, like my algebra students are testing on this tomorrow, and this is probably most of their favorite one, like in terms of understanding and just like yeah, being able to successfully complete the problem. So we'll talk about what we need to do, and with my algebra class, these are actually notes from my algebra class. A lot of times I write steps out because I'm very methodical and that's the way I think, and so that's usually why there's steps written in most of these. And so factoring with our leading coefficient of 1. Basically what that means is it's starting with an x squared. So there's no number in front of the x squared. So if you guys see that, all of these start with x squared. So that's how we know it's this type of problem. And it has 3 terms. And so we know in order to do this, that it's always going to start with x squared. So actually going back to this way, real quick here. I know that's where the x and x come from. X times x gives me x squared. So that's how I know it's going to look like that to begin with. Now the second half of this is definitely the tougher part, but still not impossible. So I want you guys to notice a couple of things here. So I end up with a 15 and an 8. I want you to look at these numbers here and see how I could get a 15 and an 8 from them. Do you see it? With 5 and 3, how can I get 15? 5 times 3 is 15. How would I get 8? 5 plus 3 is 8. So that's not a coincidence that that's what we have going on there. Is we're multiplying to get that last number and adding to get the middle number. So let's see if that works on this one. So again, we have a negative 12 here. 6 times negative 2 is a negative 12. But then 6 plus a negative 2 is a positive 4. So again, that's not a coincidence. And I'll tell you, looking for the one we're multiplying to get is a little bit easier to start with. So that's why I say it's like a puzzle, a little bit of, just a little bit of a mind game here. But I'm also someone who likes those types of things, so I understand if that's not your thing. But at the same time, I think everyone's capable of it. So we're going to start with this as x and x. So start with so every one of these problems for our homework for this part of it are going to start with the x and x. So you could go through and put all like the start of these problems for our homework as x and x. Now the second half of this is the c value, the last value, is the one I want to multiply to get. So we're going to go for that first. We want to find numbers that multiply. So I'm going to write that a little bit differently. So I said find values that multiply to C. And when I'm talking about C, C is always the constant, it's the one without a variable. So we want to find numbers that multiply to get us 12, and those are trying to find factors. So I typically, like with my algebra students who aren't great at finding factors, I kind of make a list with them. I start with 1. 1 times 12 is 12. 2 times 6 is also 12. 3 times 4, and I've kind of, that's my whole list. I just counted out 1, 2, 3, and now I'm at 4 again, so that obviously works. So that's our list of factors. Now out of that list, we're going to use the set of factors that will add to give us B. And there's only going to be one set that works. 1 plus 12 would be 13, 2 plus 6 would be 8, 3 plus 4 is our 7 that we're looking for. So that's what's going to go in the parentheses. And if you can't find the factors, either you need to look a little harder for like more of a list. Otherwise, it's possible it's not factorable, but I don't usually give many questions that aren't factorable. All right. And again, this is something going into Algebra 2 or other math classes that it's just nice to be comfortable with this. So again, we start with x and x. So the number I want to multiply to get is negative 18. But then I want to add to 3, positive 3. Now when there's a negative number involved, it's a little bit trickier. Because if I'm multiplying to get a negative, what needs to be true about my numbers? What's true about my numbers? What's that? One has to be negative, one has to be positive. Yep. So like we do like 1 times 18, negative 2 times 9, negative 3 times 6. That's our, well, then we reverse the list. And obviously you don't have to write this list every time. This is just like kind of what I'm doing in my head. And out of that list, only one of them adds to give me 6, which technically is like 6 minus 3, which is a positive 3. So negative 3, positive 6. And the order you put in doesn't matter as long as the 6 is positive and the 3 is negative. Okay? So again, for our homework, I did throw a few GCF problems at the start of it, but the second half of it, all the problems are going to start with this. It just depends what variable it is. So let's flip the page over. Nothing's different about this. Nothing gets crazy halfway through this problem. So there's a couple that are a little bit strange in terms of just like what's missing from the problem. So why don't you guys look at 3 and 4 if you can and see if you guys can figure those out. Again, you can set up your little X's right away. And I always feel like these are like the answer to a riddle. Once you hear it, you can't unhear it. So trying to come up with them on your own is a good idea. You don't like those? Yeah, those are a little bit weird. Okay, that's fine. So yeah, working through these, and some of you guys are like already figured this all out and you remember this, or this just makes sense to you and you got it, but. The next one is kind of strange here, this number 3, because you're multiplying to get a positive 27, but adding to get a negative number. So they're both going to have to be negative. So 2 negatives will multiply to give me a positive, but when I add them, they'll give me a negative. So they're both going to be negative in this case. And number 3, if you're still working on that one. So the one that adds to give me a negative 12 is minus 3 minus 9. multiplying to get my negative 28. And again, the list is not necessary. It's just like, it's what I kind of rattle through in my head, but I also like do this as my job. So they come quickly to me. So we're gonna have a negative 7 and a positive 4. And again, that's why I like this. It's like a puzzle piece that only fits the one way. You can't flip those signs. They have to be with those numbers. Now 5 and 6 are probably as tough as these kind get. So if you're like, this is really it, I mean, this type, we're going to talk about a different kind on Monday that we have to factor that's not quite this straightforward. But these ones, I think these are kind of the toughest this gets. So number 5, what are we multiplying to get? What are we multiplying to get in number 5? Negative 20. What are we adding to get? X, what's in front of the X? There's a 1. So we're adding to get positive 1. So since the X is there, they don't write that 1, they assume you know it's there. It's kind of a silly assumption, especially for math students, but as you move along, it's nice to not have to write it all the time. And once you see it that way, hopefully that makes a little bit more sense. Because if you do negative 1 and 20, and 10, and so the one that will add to give me 1 is 5 minus 4. Plus 5 minus 4 gives me a positive 1. So in number 6, what are we multiplying to get?
16.
We're multiplying to get a negative 16, but what are we adding to get? Nothing. So nothing in math is 0. So we're trying to add to get 0. And initially you might kind of be like, oh, that doesn't make sense. But once you realize this is a negative, if I add a positive and a negative together, they're going to cancel. They'll give me 0. So this will be x minus 4, x plus 4. Eventually, I think those become some of the easiest ones to factor once you notice it. But if you don't notice that it's adding to get 0, it's probably tough. All right, and let's finish up the last 2. And for whatever reason, I think these kind of stump some students because a lot of times they'll skip this set of factors. Where is it? Okay. So we have x and x. We want to multiply to negative 21, but add to 20, positive 20. And you might go 3 and 7, I don't know what else, negative 7, 3, that nothing works. But don't forget about 1 always goes into a number. So negative 1 and 21. Together, negative 1 and 21 will add to give me a positive 20, 20 minus 1. And kind of the same thing happens on this last one. We want to multiply to get positive 3, but add to get a negative 4. And the only way to multiply to get a positive and add to get a negative is they both have to be negative. And this is our only option that multiplies to give me a positive 3, but adds to give me a negative 4. Okay, so you guys, your homework is the 2 days together. So it's yesterday and today. Yeah, yesterday. So it starts with yesterday's notes, so like the GCF, and then it gets into what we just did today. So just kind of trying to review those and kind of keep that. A lot of times when I teach different types of factoring, students will forget the previous one, so I kind of want to keep kind of building on these. And we're going to do the whole worksheet.